Right, this is your Unit 12 review sheet. Okay, find the exact value without a calculator. All right, do you know what to do here?
So sine is y, right? So you would have to like just find the y value. Is that what you do?
Okay, the 75 degrees is not one of our reference angles. So you have
Yeah.
to come up with two angles that either add to 75 or subtract to 75, where you can actually use those two angles. So the reference angles that we need to use are 30s, 45, 60. That's in the first quadrant. You can use others as well.
Okay.
If you notice that 30 and 45 add up to 75, right?
Yeah.
Okay, so we'll convert this to sine 30 plus 45, like that.
Okay. Oh, so in the same parentheses?
Yeah, because we're just rewriting 75. Okay, no, so we can't find 75 with just by using our just doing it by hand. So, but we can work with sine 30 and sine 45, right?
Yeah.
But what do we do with this? What is this called? Now notice the angle inside here is they're being added. This is called sum. So this situation is called sum and difference of trig functions. There's a formula that you have to memorize to expand this. This will expand to sine 30 cosine 45 plus sine actually you can just do like this, cosine 30 sine 45. Do you remember this at all?
I didn't. Oh, wait, I think I do actually. I just
Okay.
don't have it memorized. Yeah,
Do
cosine.
you have the formulas with you?
Yes. It's somewhere. Oh, here it is. Okay.
Okay, so this is the sum and difference formula that you have to know. In fact, there's actually several more you have to know. This one and you have to know all of these. Sum and difference as well as double angle formulas.
Okay.
Okay.
I don't know if I'm just not seeing it, but I don't think this one's in the packet that I have.
This one? Oh, you mean it's in your
Like,
book. Yeah.
oh,
You
okay.
have to look at your book
What
and
page? Or do you know what page it is?
it's in 7.5 and 7.4. Just go to the section
Okay.
7.5 and 7.4.
Oh,
The page
thank you.
numbers, you should be able to find it by
Yeah.
sections.
Okay.
All right, so do you know why this is being used or what the purpose is for this one?
No, I'm not sure.
Okay, so the purpose for these, actually for all of these, is when you're given a situation where the number's not part of the unit circle. 70, we haven't done anything with 75, right?
Yeah.
You want to convert it so that you can use the 30s, 45s, and what?
The
60s.
60s.
Yeah. And do you remember the chart that I gave you? The one that I've told you several times to memorize, this one?
Yeah. Mm-hmm.
So when you take your test, this is the first thing you want to draw on the back and
Okay.
always refer to it. 30, 45, 60. This is pi over 6, pi over 4, pi over 3. 1/2, rad 2 over 2, rad 3 over 2, rad 3 over 2, rad 2 over 2, 1/2, rad 3 over 3, 1, and rad 3. Okay, so the values for sine, cosine, and tangent, they all revolve around these reference angles, 30, 45, and 60, or pi over 6, pi over 4, and pi over 3.
Okay.
Okay, and these are your values. And again, these are just your first quadrant values, so you have to figure out if it's going to be positive or negative. So again, you have a situation where it's sine 75. There's no way you can work with this, but you realize, hey, if you just combine 30 and 45, it adds up to what?
75.
Yeah. So look at this. This? Whenever you have two angles being added, you can break it down into this situation.
Okay.
You have to memorize like this: sine, cos, cosine. You see it?
Mhm.
So for both sides, it's always going to be sine, cos, cosine, and the signs are going to follow. Like if this is positive, this will also be what?
Positive.
This is negative, this will be negative. The
Mhm.
cosine, if you take a look, you see another pattern: cos, cos, sine,
So,
sine, right?
mhm.
But the signs there are different. If this is positive, this is what?
Negative.
Negative, and this is negative, this is
Positive.
positive. So all you have to do is just plug it in. And so basically, this becomes that, okay? Or
Mhm.
let's do it like this. Sine 75 becomes this, and that opens up and becomes what?
To the
That?
left.
Yeah,
Yeah.
and now I just do it by hand. What's sine of 30?
Sine of 30 is
Okay, look at this chart. Okay, did you write this down? Okay,
I
copy it
wrote
down real fast. So you always refer to this. You don't want to use the unit circle anymore. You want to rely on this chart. It basically gives you all of the answers.
okay. And is there any other ones that I would need to know, like besides or that are not on this chart?
Um, there might be one more, but I don't see the half angle stuff being used. We'll see. If it's on the review guide, I'll let you know. Okay, so
There's
look,
30.
sine of 45 is what?
Pi 2 over 2.
Yeah,
Not pi 2, sorry,
sine
rad
of
2 over 2.
45 is rad 2 over 2, right?
Yeah.
So just plug it in. Oh, actually, no, this is sine 30. What's sine of 30 according to the chart?
1/2.
Yeah, see?
Mhm.
And what's
And
cosine of 45?
rad 2 over 2.
And what's cosine 30?
Rad 3 over 2.
Yeah, and then what's sine 45?
Yeah.
See?
Oh, rad 2 over 2.
Okay, so this is okay. So we're now doing sine 75, but we're doing it by hand now, and all you have to do is just multiply this out and add it. Let me move this down. Okay, so we got what is this? Rad 2
2
over
over
4 and rad 6 over what?
4.
And then the denominators are the same, so you want to write this as rad 2 plus rad 6 over 4, and this is your final answer. So sine 75 degrees is equal to all of that.
Oh, okay. And then I don't have to like simplify it further, right? Since it's just. Oh, yeah. Never mind.
No. Cosine of 5 pi over 12. So you're looking at this and you're thinking, oh no, I don't even know what that is. Well, look at your chart again. Do we have any denominators with 12 in it?
No.
It has to be made up of 6, 4, and 3. Do you see that?
Yeah.
So how do you figure out combination of which two adds up to pi over 12? Well, here's an easy way to do this. All you have to do is break up 5 pi into two fractions with a denominator of 12. And something that can go into 12 as well. So how about 3 and 2? So 3 pi over 12 plus 2 pi over what?
2 pi over 12.
Okay, now tell me if that makes sense. Because as a fraction, if you add it, it will eventually become 5 pi over 12, right?
Yeah.
Now, you can also do like 4 pi over 12 plus pi over 12,
Mhm.
but if you do it that way, it's not going to reduce down. Okay, so if you take a look, right now the denominator is a 12.
Yeah.
If you reduce this, what would that become?
Pi over 4 and then
Yeah.
pi over 6.
Okay. All right. So notice the denominators now. You have a 4 and a 6. Isn't that basically what we need to use the chart?
Yeah.
Yeah. Okay. Now, before you do that, you have to use this formula and expand it. So go ahead and expand it. You see this?
So cosine.
So cos sine, sine,
And
and the signs will change, okay?
So cos, sine, sine.
Yeah, so cos pi over 4, cosine pi over 6, and then minus sine pi over 4, sine pi over 6. Okay, see how that works?
Yeah.
Okay, so let's just stop for a moment. Does this make sense? Like we took
Yeah,
5
that-
pi over 12. We have no idea that it was, these two added together. So what we did was we split the 5 into a 3 and a what?
And a 2.
Now again, you can use 1 and 4, but 4 will work, but pi over 12 is not going to work, right? So I decided use 3 because 3 and 12 can be reduced and 2 and 12 can be reduced. And then you just use the formula, the sum and difference formula for cosine, which the pattern is cos, cosine, sine. Now, list it out. What's each one here?
Rad 2 over 2 times rad 3 over 2 minus pi rad 2 over 2 times 1/2. And then rad 6 over 4 minus rad 2 over 4.
Rad 6 minus rad 2 over 4. Okay. Did you get that?
Yep.
Try. You're going to try letter C, D, and E by yourself. Actually, I'll do one more.
Okay.
E is just working backwards. You notice that this is cos, cosine, sine. So
Yeah.
it's referring to which sum and difference formula?
It's the, which one is it? The cosine minus sine? Is that the one? Cosine minus sine?
Okay, which one? So this is a cos, sine, sine with the plus in between. So it's using this formula right there, right?
Yeah.
So if you see that, you can convert it back to this one.
Mm-hmm.
You see it? So it'll be u minus v. So here, u would be 15. V would be what? 60. See that?
Yeah.
So it'd be u minus v. So just replace those. It'll be cosine of 15 minus what?
15 minus 60.
Yeah. And if you do 15 minus 60, what is that? What's 60 minus 15? 45?
Mm-hmm. Is it?
Okay.
Wait,
Yeah.
do you have to do negative or do you just? Oh, okay.
Yeah. Cosine of negative 45. Okay. So how do we do a cosine of negative 45? We'll use the chart. What's the digit answer for this? Everything cosine 45 will be what?
Pi over 4.
No. Look at the chart again. What's the value of cosine 45?
Value. Oh, rad 2 over 2.
Right. But the question is this. Is this going to be positive or negative? Well,
would it be negative?
Okay, so just watch. So even though we're doing a negative 45, because the reference angle is 45, the value will always be rad 2 over 2 as a digit.
Yeah.
Now we just have to figure out if this answer is going to be positive or what?
Negative.
Well, what quadrant are we in if we're going negative 45 degrees?
You would be in quadrant 4.
Right. So if you go down 45 degrees, you're in quadrant 4. Are cosine values positive or negative in quadrant 4?
It would be positive, negative 4.
Yes. So the answer here will be a positive rad 2 over 2.
Okay.
You're just working backwards with the
Yeah.
Right. Okay, let's start with the identities.
Okay.
All right. Do you know how to do this one?
2.
Pretty self-explanatory, right?
Yes.
What would you do to turn this into a 1?
Would you do the opposite first? So it would be 1 cosine y times cosine.
You mean the reciprocal? It's not opposite. Reciprocal, right?
Yeah, reciprocal, right? And then it just cancels out.
Yeah. Okay. That'll be it for that one. Here. All right, now, okay, so for these, did you memorize the Pythagorean theorem identities like sine squared theta plus cosine squared theta equals 1? Did you memorize
Yeah.
that? Did you memorize the other one? Tangent squared theta plus what?
Plus 1 equals secant squared.
Squared theta? And what's the last one?
1 plus cotangent squared equals, what is the last one?
Cosecant squared theta.
Oh, cosecant, okay.
All right. Yeah, so make sure you get those memorized too. Okay, so what do we do here? Well, do you notice that on the left side you have a cosine and sine, but on the right side there's no sine, right?
Yeah.
So there's a big hint. This must have been replaced out. Does it make sense?
Okay.
So what did they replace that with?
You replaced it with the 1 minus cosine?
Right, there you go. Okay. And then, can you see how I wrote this? Cosine squared alpha minus, and you put this in parentheses or bracket.
Yeah.
Now you just start distributing.
Mhm.
And then you'll notice that you have cosine squared alpha, two of those. They're like terms, so you can add it. So it'll be cosine squared alpha minus 1. And there we go.
Okay.
So what do we do with this guy here? Now, when you look at this, you should see on the left side, there's two fractions. It's cosine x over 1, sine x tangent x over 1. On the right side, you have one fraction, secant x over 1, which basically becomes 1 over what? Cosine of x. You see that?
Wait, I think the numbers might be different. Sorry. Is it cosine x squared? Oh, yeah, this one isn't on it. I'll just add this one then.
Oh, this one's not on your review guide? Which one's your number 5?
It's 1 minus cosine 2x equals tan squared x, parentheses 1 plus cosine 2x.
Okay, say it one more time. 1 minus
Cosine 2x equals tan squared x, parentheses 1 plus cosine 2x.
plus cosine 2x. Oh, like that?
Yeah. 1 minus cosine 2x. Yeah.
Yeah. Okay. Okay, this one's a tough one for students. Okay, do you recognize this? What do you call this guy?
Is it?
Okay,
Is
so you
it,
see how the angle is being doubled? It's called double angle formula. You see that?
Okay.
Yeah. By the way, are you sure? Wait, is this cosine 2x or cosine squared x?
Cosine 2x.
Cosine
Yeah, it's
2x?
cosine 2x on both sides. The only one that's squared is the tan.
Okay, all right. Okay, so now what that means is we have to go back to our formula chart.
Okay.
Okay, do you see all these double angle formulas right here?
Yeah.
Here's cosine 2u. Now, sine and tangent, you only have one each, but cosine has 3 equations to pick from.
Okay.
But you only need to memorize the top one because you can derive the other one. Like the second one, they just replace sine with 1 minus cosine, it becomes that.
Yeah.
This. And then for the last one, they just replace this with 1 minus sine squared theta, which eventually becomes this.
Okay.
So these two are derivations of the top one. So you just have to memorize this guy right over here, okay?
Okay.
All right, so cosine squared u minus sine squared u. So we go all the way down. And now the question is, okay, which side do we start? Here, let me write it first. Let me just write the cosine. Let me use a different color. Cosine 2x is equal to cosine squared x minus sine squared what? X. Okay, so where do we start? Well, usually you want to start on the side that has a higher exponent and work your way down. So So how do we do this? Well, I'm going to start on the right side.
Mhm.
And first, I'm going to convert this into that. Okay.
Okay.
And let's see if this works. Now again for most of these, you don't really know where to start usually, unless you've done like millions of these problems. Um, I can do some of it in my head and kind of know like if it's gonna head in the right direction. But you just have to kind of
Mhm.
start, and as long as you follow the rules of math, you'll eventually get to the other side. So let's try this. So this is tangent squared x, 1 plus cosine squared x minus sine squared x, like that, right?
Yeah.
Okay. Now I'm thinking I need to somehow get a 1. I have a 1 right there. But if I distribute this, what's going to happen? Okay, so now I'm going to unpack tangent squared x and turn that into a sine squared x over cosine squared x, like that. Do you see it?
Yeah. So sine squared x
Now
over.
you might be asking, well, how did you know you're supposed to do that? Well, I didn't, it's not like I knew anything, but I thought, you know what, if I'm going to distribute this in, it might cancel the cosine squared x out right over here, right? So I'm going to distribute this in. So this is sine squared x over cosine squared x. And then plus, and this will just become sine squared x because the cosines will cancel out. And then
Yeah.
minus sine fourth x over cosine squared what? X. Okay. Now, well,
Squared
let's
x.
see. Let me write it like this. Sine squared x times sine squared what?
Squared
Okay.
x.
All right. Are you following?
Yeah.
Okay. So let's see. Where are we
Why
going
is
with
it
this?
best to write it?
Say
Why
again?
would it be better to write it as like sine squared x times sine squared x instead of just the sine
Oh,
sine
4x?
to x? Yeah.
Yeah. Well, yes. Okay. So yes, you can write it like that. Sine to the fourth power of x. But I'm gonna hold off because I think something's gonna eventually cancel out,
Oh,
and I'm gonna
okay.
need it to be. I'm gonna need it. I'm gonna need it to be factored. Now the
Yeah.
reason for that is also if you look on the left side, there's no fourth power. Do you see it?
Mhm.
So I was about to write it this way, and I thought, okay, maybe I should just leave it like this, just temporarily, to see if maybe something's gonna factor out or cancel out. So okay, so this is. Let's see what's gonna happen here. Oh, so do you notice that these two have common denominators, right? And we have three fractions with um, different denominators. Okay, so the first thing I'm going to do is try to get common denominator for all of them. And wow, this sounds really tricky. Okay, so I'm just going to keep going. Let's see, this will be sine squared x over cosine squared x plus sine squared x on the bottom. So this is going to need an extra one. Okay, so this would be sine squared x over cosine squared x. Oh, I'm so dumb. This is supposed to be cosine. Sorry. So this is sine squared x times cosine squared x because the common denominator is cosine squared what? Cosine
Cosine
squared
squared
x.
x. Mhm.
Whoa, okay, so now we have one fraction, cosine squared x, and the numerator looks pretty crazy.
Yeah.
Squared x cosine squared x minus sine squared x sine squared x. Huh. Well, that's not going anywhere. So, should we keep going or should we stop? Well, let's see. If I factor out a sine squared x, I'm going to get that. No, that's not going to work. Okay. So this is where you'll just kind of hold off and say, okay, maybe I should try a different route. All right, so let me leave this here and move this over. And let's try this. 1 minus, let's see, cosine 2x equals tangent squared x 1 plus cosine 2x. Oh, Wait, was that it? Here, is it? Can I turn this into, let's see. So bring the tangent to the other side, right? So this would be secant squared x minus tangent squared x. Let's try that. Secant squared x minus tangent squared x minus cosine 2x. Now I have a tangent, which is right over here.
Mhm.
But how do I turn this into that? So is it basically this? So negative tangent squared x plus secant squared x minus cosine squared x minus sine squared x. So I'm going to open that up. And then I'm going to leave the tangent squared x by itself. And then I'm going to turn this into 1 over cosine squared x minus cosine squared x plus sine squared x. What in the world is going on here? I'm actually like stumped.
Maybe
There's
it was, I don't know. Maybe they like meant to do it as squared instead of 2. Like she hasn't said anything about it being like squared instead of 2x, but sometimes like later on she'll tell us that there was like a mistake. But
yeah,
I'm not sure.
that would be unfortunate.
Yeah.
Well, see, okay, now you see how long this is going? I can actually keep going,
Yeah.
but usually for high school problems, you normally stop around 4 or 5 lines because it's not going to be that hard. So there's always like a small trick that either I'm missing. Um, Here, why don't you try the next problem? Let me keep working on this. Which
Okay.
one's your number 6? What does your number 6 say?
It's secant y minus 1 over 1 minus cosine y is equal to secant y.
Okay, so give that a try. And let me just kind of work on this on the side. Um, I'll just do it on the side, and I'll send you the solution.
Okay.
So that we can just finish the other ones.
Yeah.
Okay, so number 6. Well, just crop it out. Okay, so this guy. Okay, so obviously we're gonna work from left to right. Secant will become 1 over cosine of y,
Mhm.
this. And it's a complex fraction, so basically take the top, get common denominator. The denominator is going to be 1 minus cosine of y over 1, right? The numerator is going to look like this. Cosine of y over cosine of y. Can you see that?
Yeah.
And then you always want to combine fractions and then, work with one fraction on top, one fraction on the bottom.
Okay.
So this would be 1 minus cosine of y over cosine of y all over 1 minus cosine of y over 1. Okay, so notice you have one fraction on top, one fraction on the bottom. And what do you do with the denominator? You flip it and you multiply to the top, right?
Yes.
But you want to rewrite it on the bottom like this. cosine of y times 1 over, oops, let me just use a different color here. 1 over 1 minus cosine of y. And you notice that these two will cancel out, cancel.
Mhm.
And you're left with 1 over cosine of y, which becomes secant of what?
Secant of y.
Yeah, okay. All right, so yeah, max 5, 6 lines. 1, 2, 3, 4, 5. But if you have to go further, just probably missed the trick. All right, number 7. All right, this, okay, now do you notice that this is a double angle right over here?
Yeah.
Sine 2x will expand to 2 sine x cosine of x, okay? So you want to keep that in mind because what's going to happen is on the left side, you're going to see a 2 sine x cosine of x, and you have to immediately recognize that it turns into sine 2x. All right, so this is telling us what to do. Just square the whole thing. So this is like this. You want to square like this. Sine of x plus cosine of x. Okay, and you want to distribute everything out. Sine times sine and sine makes sine squared x. And then this times that will become sine of x cosine of x. And then the middle two will become sine of x cosine of x. And then the last two will become cosine squared x.
Mhm.
Okay, all right, I already see the answer. So do you realize that these two in the middle will become 2 sine x cosine of x?
Yeah.
Yep. And then the two on the outer ends, the sine squared x and cosine squared x, isn't that your identity, which equals to 1?
Oh, yeah.
Yeah.
I think I forgot.
Yeah. And then you realize, oh, there's my double angle right there. So this is 1 plus 2, oops, 1 plus sine 2x. Okay. All right. So again, on the left side, wait, can you double check this is your number 8?
Number 8. Yes. Yeah, it's the same one.
Same one? Okay. So again, which side will we obviously start on? The left side, right?
Uh,
Yeah. So again, remember, we're just basically using algebra, not trig. We're using trig stuff, but treating it like algebra 1, meaning there are two fractions with different what? Denominators.
Mhm.
Wait, did I cut in and out? Are you still there?
Yeah, it was cutting out a little bit.
Okay, so again, there's two fractions with different denominators, and algebra 1 tells us just get the two fractions, get common denominator, and then what? Combine it.
Mhm.
Okay, now so also notice, here we have two fractions. On the right, how many fractions do we have?
Just one.
Just one. So whenever you have two fractions and one fraction, it had to have been combined. Does that make sense?
Yeah.
Yeah. Okay, so what's our common denominator? Well, this one's kind of big. It's cosine theta times 1 plus sine, handwriting. Cosine theta and 1 plus sine theta. Cosine theta, 1 plus sine theta. Okay, got it? Does that make sense?
Mhm.
So the numerator will just be the extra stuff being multiplied to it. So we got this. And on the other side, you multiply an extra cosine theta. So it'll look like that. Denominator will be cosine theta, 1 plus sine theta. Now, normally leave the denominator like the way it is, meaning don't multiply it out. Usually something will cancel out, okay? So you want to leave it like that. Now the numerator, you want to multiply everything out and try to combine like terms. So so if you multiply this guy, you have to distribute that out. That'll become, and I'm just going to do this really fast. 1 plus 2 sine theta plus sine squared theta plus cosine squared theta. Is that?
Yeah.
Okay. All right. Just let me know if I'm going too fast, okay? So tell me when you're here. Are you here?
Yes.
Okay. Now, is there something we can just cancel out immediately? Or combine or simplify? Do you notice that these two right here should equal what?
1.
A 1. There you go. That's a 1. And then 1 plus the 1 in the front will make a 2, right? So the numerator will have 2 plus 2 sine theta. Oh, and then the denominator is cosine theta 1 plus sine what? Theta. Now you should be able to see that you can factor out a 2 from the top, right?
Yeah.
So it'll be like 2, 1 plus sine theta, and you realize, hey, we can cancel it out, right?
Yes.
Theta. Cancel, and what do you have? 2 over cosine theta, which becomes 2 secant what?
2 secant x, or not x, theta.
There we go. Okay. All right. All right, now this one, you have to actually know this. It's called a cofunction. Let me show you the equation.
Oh, is it equal to, wait, what is it, sine pi? I think I remember seeing this. I wrote this down somewhere.
All right, look.
Yeah.
This is called cofunction identities. This is at 7.1.
Okay.
Okay. All right, now it's not too hard. It's actually pretty easy to memorize. Sine and cosine are cofunctions, and what this means is whenever you have like a 90 minus u or pi over 2 minus u, you just basically give the u to the other side, give it to cosine. So if you have like a cosine of 90 minus u, just give the u to what?
To the other side.
Yeah, they just because they're cofunctions. Well, there's a whole explanation behind this, which I don't have time to go into, but they work together. So since sine and cosine work together, so if you saw this, you can give this x to who?
To the other side.
No, well, not this side, because remember we're trying to prove that this becomes that side, right? So do you see it? This is equal to what? That.
To the,
So sine of pi over 2 minus x is this, which is equal to that. So it's just like, you don't have to do anything here.
Yeah, you just restate it kind of.
Now let's say that you just totally forgot, right? And I think they want you to do it this way. Do you recognize that this is the sum and difference formula? Remember do you remember the pattern? Sine, cos, cosine?
Yeah, sine, cos.
I think Miss Town wants you to do it this way, okay? So you can say, I'm using cofunction and just write that down and you're done, right? But if she says, no, I want to see you work, then you have to expand this out to sine pi over 2 cosine x minus cosine pi over 2 sine what?
Pi over 2. Or x.
Sine, cos, cosine. This is that
Pattern?
right. You remember this one?
Yes.
This one here, right? Okay, so watch. Now simplify it. What's sine pi over 2?
It's...
Now, this one's not on the chart because this one you should know just from looking at it. At 90 degrees, what's the y value? How far did the radius go up?
Oh, 1.
1. So this is 1 and cosine of x. And what's cosine pi over 2?
Cosine pi
Cosine
over
is an
2.
x coordinate, right? So when you
Yeah.
raise the radius to 90 degrees, the cosine value or the x coordinate is
0.
0. So it's just cosine of x. You get it?
Oh, okay.
Okay. Now, you should ask her, can I just use the co-function identities? And she'll say, did you memorize it? I don't know. I don't know. I actually don't know what she's going to say. But if you ask her, then do you mean for us to use the sum and difference formula? Then this is what it is, okay?
Okay.
Ding, ding. Um, yeah, do you see that? This is the sum and difference formula for tangent.
Yeah.
This one? Yeah, remember this one right here?
Mhm.
So, okay, now I'm guessing, okay, since it's literally just that, she actually wants you to like multiply it all what? All
Multiplied.
out. Yeah, you have to prove it. So you can't just say I'm using the formula, the left equals the what? The
The
right?
right. Yeah.
So if this is on the test, she wants you to actually prove that the left becomes the right side. Okay, so are you ready? This is actually gonna be pretty intense. So we're gonna start by writing it like this. Sine x
Okay.
plus y over cosine of x plus what?
Cosine of x plus y.
Yeah, okay. Now I understand that the right side is actually more complicated, but in this case, um, we have to work from the left because we have to use what we know to expand it. Okay, now this is your sum and difference formula for sine and cosine, right?
Mhm.
So let's start expanding it. This will become sine x cosine y minus sine cos cosine, sine cos cosine. So this would be cosine y sine what?
Sine y.
So the
Sine x. Sorry, I
cosine,
keep
yeah,
opposite.
cosine
Sine.
x, yeah, sine y.
Oh,
Yeah, and the denominator will become cosine of uh, cosine sine cos x
sine
cosine y minus sine x sine what?
sine y.
Sine y. Okay, now you're looking at this and thinking, okay, what do I do next? Well, there's a little trick that you have to see. So you kind of glance at the right side. You're thinking, okay, I see a negative. I see a negative on the top. I see a, oh, this is a positive. Sorry, I see a positive. So the sign's matching up. And how do I turn this right here into a tangent of what?
Tangent of x.
Yeah, and where this will become tangent of what?
Tangent of y.
Of y. Well, to make this into a tangent of x, you have to divide this by cosine of y, right?
Yeah.
Cosine of y. Um, so that, well, no, sorry. You need a sine of x, cosine of y. So, let's see, is there an easier way to show you how to do this? Because, okay, do you remember Miss Town said you can work on both sides? Do you remember that?
She only lets us work on the left side, I think, or like the left or the right, not both.
One or the other, right? I don't know, for this one, um,
I can ask her tomorrow because I have her class tomorrow.
okay, I did all of it in my head already. So, um, there's no way she'll teach you this method that I'm doing right now. So basically for your class, this one you actually have to do it from both sides um, to understand where it's going. So uh, okay, watch. Oh, you know what? Okay, I got it. So yes, let's okay here. Yes, you can. Yes, you can do it on one side. Here we go.
Should I erase
So
it too?
well, okay, no, actually leave the left side because you actually need it.
Okay.
Here, let me undo. Oh, can I undo it? Can't undo it. So you just leave your left side on, and you'll see what's gonna happen. Okay, so let's start on the right side,
Mhm.
and this will become sine x cosine of x plus sine y cosine of y, right? And then this
Yeah.
will become 1 minus sine x cosine of x sine y cosine of y. Okay, now watch. When we start doing common denominators, it's gonna look like the stuff that we just wrote. So the numerator, the denominator is cosine of x cosine of y plus cosine of x cosine of y, and the numerator will become sine x cosine y, and then this will become sine y cosine of what?
Cosine of x.
Cosine of x. Okay, is that okay? I just got common denominators and made it into equivalent fractions.
Okay.
So let me know. Let me know if anything's confusing here. Now the bottom, the common denominator is already given to us. Is cosine of x cosine of y right there, right?
Yeah.
Okay, so watch this. So this is gonna turn exactly into what we had on the left side. Sine y cosine of x. Okay, so a couple more lines and we're done. Combine the two fractions on the top, which will be cosine of x cosine of y, and this would be sine x cosine of y plus sine y cosine of x. The denominator is going to be written as cosine of x cosine of y minus sine y cosine of x all over cosine of x cosine of what? Y. Okay, do you see how it's gonna, these two are gonna cancel out?
Yes. Would you do the
This one will
reciprocal?
flip. Yeah, this will flip.
Yeah.
So this would be sine x cosine y plus sine y cosine of x all over cosine of x cosine of y times. Okay, so your hand must be screaming by now because it's like so much work writing this out. Okay, so cosine of x cosine of y minus sine x sine y. Okay, and then we cancel, cancel. Ta-da, see it?
Yeah.
Now, we're almost done. Sine x cosine of y. Now I'm going to change the order of that first one right here to cosine x sine y, just so that you can see it better. This is cosine of x sine y, and then all over cosine of x cosine of y minus sine x sine y. And here's where you have to recognize, oh, this is the sum and difference formula for sine and what? Cosine. Do you see it? The one on the top becomes sine x plus what?
Y.
Y. Do you get that?
Wait. I wrote it as squared. Sorry.
Yeah.
So sine x.
And the denominator becomes cosine x plus what?
X plus y.
Okay, you see that? And that eventually becomes sine over cosine, which is what? Tangent x plus y. Okay.
Okay.
So 1, 2, 3, 4, 5. Okay, 6. This one has 6 lines. Okay, so you see how, yeah, this is now, you recognize that on the other side, we went backwards. We went here to here to here, right? And then we kind of just stopped. And then I realized, oh, okay, what they mean is start from the other side, work our way down. But you have to recognize this, that sine x cosine y, cosine x sine y, that is basically this guy right here.
Okay, so just knowing the formulas, right?
Yeah, so you have to know the formula. So yeah, she just basically wanted you to actually derive it. All of these are derived. Like one guy just sat there and just kept on going, and it's like, oh, here's another one. And so So they're seeing if we can follow through with that. Okay. Well, you can definitely rewatch the video. So
Yeah, I'm going to.
the next one. Now the rest is just solving this one. Like, okay. So solve the equation in the interval 0 to pi. So again, you want to treat it like a quadratic. Like what would you do if it was like 2x squared plus x? Wouldn't you factor out an x and set it equal to 0?
Yeah.
It's pretty much the same idea. So
So
this would be like
one.
cosine x, parentheses, 2 cosine of x plus 1. See that?
Yes.
And then set each factor to 0. Cosine of x equals 0. 2 cosine of x plus 1 equals what?
Equals 0.
And then you have to figure out what values of x produces 0 for cosine within the interval 0 to 2 pi, like from one revolution or one full like circle. Well, the only time x is 0 for cosine is when it's at 90 degrees and 200 and what?
280, 70.
270. So x will has to equal pi over 2 or 3 pi over what?
3 pi over 2.
Wait, do you get that?
Yeah, it's just using the x value, right? From when
Yeah,
it's
the x value, And then for cosine, well, you have to go like this now. You're trying to isolate, well, not isolate x, you're trying to isolate a trig function. So cosine of x equals negative 1/2. All right, so now what quadrant is cosine negative?
Negative 1/2. So it would be in quadrant 2 or quadrant 3.
Yeah, okay. So in quadrant 2, what is your angle that produces a cosine of negative 1/2? Well, here, let's try this. Go to your chart. What angle gives you a 1/2 as a value for cosine? Pi over
Pi over 3.
pi over 3. So if you take pi over 3 to quadrant 2, what would it be?
Negative pi over 3.
No, like this. So here's quadrant 1, and it's pi over 3 right here, right? So what would it be in quadrant 2? It would be 2 pi over 3. Wait, do you get that?
Not really. Because are you moving it like the same amount, like pi over 3 and then another pi over 3?
Because pi over 3 is 1/3. So it's like 1/3, 2/3, 3/3.
Okay.
Okay, now if you're not used to doing that way, you might have to just use angles. So what angle corresponds to pi over 3?
60 degrees?
Yeah, so if I take 60 degrees and moved it up like this, right here, it will be 180 minus 60, which is basically 100 and what?
120.
20. Wait,
Okay.
is this making sense?
It's kind of like similar to what we did last unit, right? Like where you have to do the subtraction thing to get the.
Yeah.
It makes sense, but it makes me think about it a little bit more.
Yeah. So again, we know that pi over 3 produces a 1/2 for cosine, right?
Yeah.
So on all the other quadrants, it has to have that reference angle that many units away from the horizontal line. So in quadrant 3, you have to go down 60 more what?
60 more degrees.
Which is 180 plus 60, which is 200 and what?
40.
240. So 240, what would 240 be in radian measure? Do you know?
240, that's. Wait, I need to like write it down. I don't remember. It's
Do you remember the unit circle? This is where you can use the unit circle to figure out the radian measure.
Yeah.
240. Another way you can do this, just do like thirds. 1/3, 2/3, 3/3, and what?
4/3.
Yeah, so this is 4 pi over 3. So in quadrant 2, it'll be 2 pi over 3. In quadrant 3, it'll be 4 pi over 3. So you'll actually have 4 answers. This one, this one, this one, and what?
Oh, okay.
So yes, you do have to go back to that unit circle situation again.
Okay.
All right, here. Time's almost up. Let me try one more. All right, so cosine theta equals sine theta, and when I see this, I see a tangent. Do you see a tangent?
Yes.
So 1 is equal to tangent of what?
Tangent.
Theta?
Theta.
Okay, so what quadrant is tangent positive?
It's positive in quadrant 1 and quadrant 3.
Good. Now in quadrant 1, what reference angle gives us a what angle produces a 1 for a tangent of that value? So how to say that? Tangent of what angle produces a 1? Look at your chart.
45 degrees, so pi over 4.
Yep. So in quadrant 1 is pi over 4. But what is it in quadrant 3?
Quadrant 3. Is it negative pi over 4? Oh, wait,
No. So here, watch. You see, this is pi over 4 right here, right?
Yeah.
So remember, what I do is I use the denominator. If it's 4, that means the upper hemisphere is broken up into 4 parts.
Yeah.
So it's ready? So watch. 1/4, 2/4, 3/4, 4/4, and what?
3/4.
5.
Oh, no, 4/4. Sorry.
5/4. So in quadrant 3 is x equals 5 pi over
5 pi over 4.
4. Okay, I think you need another session too.
Yeah.
I don't think I don't think you're ready. I have time on Monday. A spot just opened up
Okay.
on 3:30. What's your schedule like on Monday?
Monday. Oh, I don't think I'd be able to do Monday, but like we haven't finished the lesson yet. Or like we haven't